Hello guys, and welcome back to my channel. So today what we'll be looking at more or less would be dependency management in Go. And what I can actually quickly do is to more or less check out a new branch so we can already get started without wasting much of our time. So git checkout page and I provide the branch. So I'm checking out the ecosystem. Okay, so what we are going to do today is more or less a bit in-depth look at Go modules. Then we look at what it means, also look at what GoSum means more or less, and then we can talk about some tricks more or less you could employ to manage your dependencies as efficiently as possible. And of course, because we don't have much to cover on this chapter, I would also like to talk to you a little bit about some of the things you could also do in preparation of getting your code ready for production. So we're going to talk about linting. We're going to talk about of course, formatting your code, standard practices, accepted Go standard practices. I will share all of this with you so that, of course, if you have to collaborate tomorrow with some others, maybe much more experienced engineers, you wouldn't look like you're a newbie more or less. So these are some of the things we'll look at in this chapter. So I also think, of course, this is going to be quite useful. So let's jump right in. So of course, simply put, the Go modules more or less are, you could think of them as a dependency management system that more or less makes it a lot easier for you to handle your or manage your dependencies. So it makes it actually a lot hassle free. So you don't have to individually take out look out to make sure that your packages and of course their dependencies are up to date, but of course this does it for you like as seamlessly as possible. Of course, this is similar to what you would have in other languages, like say Rust, where you have cargo, for example, or maybe with of course Node, where you have like npm or yarn, as the case may be. So of course, this makes it a lot easier that you have like reproducible builds. You have semantic versioning, you have dependency pruning, vendoring as well, and of course, minimal version selection. So these are some of the few things you get right out of the box with just working with Go modules. And we'll quickly, of course, I'm guessing you're not new to Go modules because you've seen us, of course, use the command every most of the time. So with Go modules, of course, you can use it to initialize a new project where you already are familiar with the command go mod init, and then provide the name of the module more or less the that you're trying to be more or less a new application you're trying to start. And with of course I'm also hoping that you already know that if you want to add a new package, you can easily do a go get, for example, or you can also quickly just write the package name into your go mod and simply do a go mod tidy. So this is also not only going to install the packages, but of course if there are packages you already have in your application that you are no longer or that you no longer need, these are also going to get cleaned up. So if you look into the go mod file, you would see that we have like direct dependencies, and down here you will also see like indirect dependencies. So there was never at any point where we had to install ByteDance Sonic, but this is already a dependency of another package that we had to install. So that's why you see most of them down here annotated with indirects, because we don't actually directly link them, but of course Go mod helps us to manage those both direct and indirect dependencies that our application have. I am also familiar that maybe you might have also seen in some cases where people use go install and go get, and you might be wondering what the difference is. Actually, it's pretty straightforward. If you're wondering, actually more or less what's the difference between like go install, go get, go mod tidy, for example, go mod download. Maybe you've probably seen people use these different commands or certain different scenarios, and you're still a little bit confused as to what they actually could be used. So the main thing more or less would be that with go install, you install a binary and not a package. So with go install, you need to install a binary, not a package. So but with go get, you actually need to download a package. So you can think of this actually as the source file, the source code of that package that you would want to get when you use a go get, it actually downloads this package for you more or less. So, but with go mod tidy, this is actually like a quite a handy command. And what it does basically is it scans your project and updates the go mod file. And of course, in the process, it downloads all dependencies that are mentioned in your go mod file, and of course, gets rid of the ones that are no longer required by your application that are still present in your go mod file. And of course with go mod download, so this only download the dependencies that you have defined in your go mod file, but it doesn't modify the file itself. So the major difference between this and go mod tidy is that when you use a go mod download and you have packages listed there, it's just going to go ahead and download it, but it's not going to do a cleanup for you. For example, if you have packages that are still listed that you no longer require in your package. So that's the difference there, guys, between go install, go get, go mod tidy, and go mod download. Again, of course, if this is confusing for you, please you can rewind the video, go back, listen to it again, and try to understand what we are saying here. Of course, the next command you might have also heard or seen people use would be go mod vendor, and you might be wondering what this means. So in essence, go modules actually supports vendoring, and what this basically means is that it allows you to include the source code of all your dependencies directly inside your project. So normally this, when you install packages or binaries, this would actually be stored more or less at your go path. So if you check your env file, I think the command is go env. I think yes. If you look at your go env file, you can always come up here to see if we can find it. Go path. So if you go to your go path, more or less when you download or install packages, it's actually stored in here. But yeah, with go mod vendor, more or less you would like to actually download the packages and then put them in your current project. So if we did a go mod vendor, more or less it's going to download the source codes of all the dependencies we have, depending on the vendor. So some could be from, I don't know, from Google, some could be from which other developers that are out there, more or less, and then it's going to download all of this and put them in our current package. That's the major difference with go mod vendor. There, of course, there might be scenarios, of course, where this might prove useful. And of course, if you also want to look into, let's say, the source code itself, and you can, this could also be one way you could go about it. And of course, if you would like to then build your package based off of this downloaded packages that you have in your that you've gotten from the vendors, these dependencies, you can actually do something like go build. And now I can actually provide the mod. Now I would want to use the vendor, because again, like I told you, when you run the initial command go mod vendor, is going to create a folder called vendor, and then in there it's going to put all those packages. So if you want to now build your project from this downloaded um, source codes that are stored in the vendor folder, you could actually basically do something like this, and then the compilation of your code will actually be based off of the content of these vendors package. Again, the difference is, of course, in there you have the source code that right there in your project, not stored at your roots, at the roots of your the gofmt path, but directly inside your package. So if we did, it's going to, of course, store that directly inside our package in here. So that's just the difference with this. And of course, maybe if we wanted to see how this could look like if we did a go mod vendor, for example, to actually see what happens, just so we also see that's or actually let's see if that actually works, and of course if it does, we would also like to see what it actually does in essence. So the command, of course, is finally done. And now, like I told you, if you look over here in the root of our project, you have this folder called vendor. And then if I look into it, I would see all of these hosts more or less. So for example, we have over here ByteDance. If we looked into, let's say, GitHub, And then under GitHub, you can see over here we have Binance, and then here we'll see all the packages, of course, the source code that's we actually got from Binance. And then apart from that, we'll also see a lot of other hosts that we have over here actually. So we have the Gene, of course, we are using the GSSE at some point. Of course, I think this is also part of the Gingonic framework that we're using. So this is what we get over here. And of course, the other things, the other packages that we have down here. And of course, apart from GitHub, we also have like GitLab, Golang itself. So these are actually like, of course, the ones provided by Golang. And then we also have like Google and the rest of it. So like we said, this more or less downloads the source code into your project. And now we can actually do a go build. And now I can point the mod, I'll point it to use vendor, and I can do something like this. And I can actually do something like this. So go build and mod, provide the file, vendor, and of course we are now asking it to not download the packages, but of course use the packages that we have locally inside the vendors folder to build our binaries for us. And then I can do an output, or I can actually not do it, and then it's going to of course save this as the name of our folder. In this case, it's called Golang guide. So that's why we have out here golang.exe. And of course, if we also provide an output path and maybe call this main.exe and build this, in the end, we would also get a main.exe file. This would be our executable, as you can see down here. And we can of course run this. Let's see main.exe. And then of course, how you see our server is up like we've always had it. So that was what I quickly wanted to show you, of course, with regards to Go modules. And I'm just going to remove all of this stuff. I don't need it anymore. So remove Golang guide and get rid of this as well. Okay, the next thing I would want to talk to you a little bit about would be about flags. So if you look over here, for example, in our main.go, we have this version here, which is more or less, we currently define it as a constant, and it's currently set at v1. And we, if you can remember, we are piping this down to our API definitions, so that when we run our app, go main.go, main.go. And when we run our server this way, you would realize from the way we set it up, of course, you realize that all our endpoints are appended or prepended more or less with v1. So this is a way that we try to version our APIs. Now, what if we wanted to set this dynamically without having to hard code it this way? Because of course, each time we run the server, we're going to get v1 no matter what. And if we want this to be a different version, what it means is that we have to go into this, our code here, and then maybe change this to v2. And we might not really want to do this, because this would not be the way to go, if you ask me, because we would want to make our app as generic as possible so we can make modifications on the fly. We might want to deploy this, and then maybe when we run the deployment pipeline, for example, we would want to then change this from v1 to v2 or whatever we want it to be. So one cool way we can actually do this would be to use linker flags, or more or less they are referred as LD flags in Go. So to modify this on the fly is actually pretty straightforward. So we use the linker flags, and I'm going to of course provide a link to the documentation if you want to read further about this. But I'm also going to explain a little bit further on what this means, but I'm just going to quickly show you. So if we wanted to build our app one more time, and then we would want to modify this version, for example, instead of const, I can define this as a variable. So we can modify it more or less. And now I can try to build my app, but now I use the LD flags. So I provide the LD flags this way, and then I need to provide a string. I need to provide some more arguments, more or less, and I'm going to explain what this means briefly. And now, of course, I need to provide more or less what I want to change here. inside this single quotes. So I would like to go inside of the main.go file, and then the variable inside is called version. And I can actually now send this to maybe v2 like this. And then now I would like to output my binary. I can call this main.exe executable more or less. And now this is going to build our app. And then what is actually going to do is more or less is we use this X flag more or less to come into our main.go file, as you can see here, main, and then I'm targeting the version, the one we have over here, and then I'm changing it to v2. So now if we run our app one more time, so the of course the executable we have output for us. I need to run it this way. So if we run our app one more time, what you will notice that is we don't get v1 anymore. Right now we get v2. And then of course you would realize our code also didn't change. It's still v1 up here. If we stopped the server and did a go run main.go, we of course should still get our v1. So using this link of flags, what happens is that we get to more or less on the fly change certain attributes of our app. And what we can actually do, for example, is I can maybe do this way, because I would like to define more arguments. And maybe down here I can provide an argument, and I can call this date. It's going to be an empty string. And maybe in here I can print out a statement. I can say fmt print line, something like this, and I say app was built on something like this, and I provide the date. And what I can do again is also to use this LD flags to modify this parameter more or less to actually use the correct time that this server was run. So that's one. So that's exactly one thing. Another thing we could do, and all we have to do more or less is to use the same old command we used for the building. So this one, and then I can come in here and provide another argument this way, of course within single quotes, and this would be main.date like this. And now I can actually use shell scripts syntax more or less. So I use my $sign within parentheses like this. I can use the date command from shell script, because of course, you know, if I go to a new tab and I simply say date, I get the current date, something like this. And then so if what I can do is if I run this command, this would build of course our app again, and now we have to run it again one more time. So we run our main.exe, and then if we go up somewhere, we would get our argument here, app was built at so time. So this is a really cool feature you can already imagine. So now let's talk a little bit about what these LD flags actually mean. So these are actually called LD flags or linker flags, because more or less they are you could actually think of them as, so if you are familiar with linking in Go, where you have the linking program in Go that basically of course links different pieces of our code together in the end to have a final binary. So this is more or less the Go, like within the go-to chain, more or less the linker within the go-to chain that's we try to interact with at when our binary is being linked and built in the build phase. You can think of it, of course, because this is happening in the build phase. So in the build phase, what we try to do is to more or less utilize these flags to perform certain modifications to our code while it is being linked and built into our final binary. That's really basically what we're doing with this. So with regards to that, of course, like we said, this is happening during the build phase. And to understand a little bit more actually what's actually going on under the hood, and of course some of the other possibilities we have, because we actually have a lot of power when it comes to what we would want to do during the build phase. What we can actually do is I'll quickly stop the server, and then we do a go help if I can type build. And then what we can do is if we scroll up here, you can see we have our LD flags up here, and then it also tells you these arguments to pass on to each go-to link invocation. And of course, besides LD flags, if you have time, you could actually more or less look through this. You can already tell there are lots of arguments that are possible, of course, um, when within the build phase, or more or less when you're building your application. And to get more insights with regards to like the arguments we use over here, when we are like over here, we had S and W, and of course this capital X. What we can simply do is simply say go to link, and now we can see all of most of the arguments we used, and even much more. So here we have S, which of course, as you can see here, it's to disable symbol table. And then if we down here, of course, we have this to disable dwarf generation. If we go up, um, if you scroll up, of course, you can see here we also use capital X. So you can see here is a definition to add string value definitions of the form import path slash name, and that was also what we did. So the import path for us was the main.go file, but of course we don't need to provide main, because again, this is within the main package, not because the file name is main, but because this is within the main package, and that's why we use main and then the name, in this case version and date. And there are tons of other arguments, of course, that could be passed, and you also of course are invited to take your time and read this through. You don't of course need to know all of this to work with Go, but the point is that to understand that some of these tools are there at your disposal, so that if you for any reason run into a problem in the future while working with Go and you don't know which direction to go, it might also be that the solution to your problem is already available within the go-to chain, and you probably just are not aware of it. So the aim of this tutorial is of course to call your attention to some of these tools, so you can take a look at it at your own disposition, and of course know that they are actually there for you to use. So you can already tell if we have our application, let's say we have, let's say, we three environments. We have a production environment. Let's say we also have like a QA environment. Maybe we also have even a test environment. I don't know. And we develop, let's say, a new version of our API, say version 2, and we would want to deploy this version 2 into the test environment so we can test if everything is as expected. So of course, you can already tell we do not need to change our source code. We only need to add comments like this in our pipeline. Could be if you're working, say, with GitHub Actions or the GitLab pipeline, or Git, or whatever um, code repository out there that we're using, just so you know you have the option to actually bake this into your pipelines, and then you get to deploy this specific version into specific environments. And that's really more or less what I wanted to show you over here. And the last thing, of course, we can talk about here would be linting. Before we go into linting, first I would want to do more or less would be to format my code. So I do a gofmt, and I think I can provide this way to get deep formatting. No, gofmt. So I can also use these flags SW. What? Yeah, of course, I need to provide the path. So of course, this was correct. I need to provide a period to show that I want, provide the path to show that, of course, this would be in the current directory where we are. So you can see almost all our source files were actually changed. So, but the point, of course, is that this would format your code according to accepted standards within the Go community. Now, of course, maybe I can actually get rid of this vendor folder. I don't need it anymore. Remove RF, and vendor cannot, what is this? Cannot remove device or resource busy. Okay, I would get rid of this later. That's totally fine. So, but what I would want to do more or less is to provide, is to talk to you a little bit about linting. So there are certain agreed upon, you could think of them as agreed upon um, methods and ways of writing Go code. So ranging from the way you name your variables to the way you define functions, the way you to more important things like when you repeat yourself or when you have duplicate copies of code and stuff like that. So the point is that with linting, you get it's quite possible to more or less sift through your code and make sure that it follows this defined and agreed procedure of writing code in Go. So to do this, of course, you would require the Golang C package. It's actually called Golang C, like this. And to download this, I would leave a link in the description so you can visit the homepage more or less to see how you can download. Basically, it's pretty straightforward. You could just curl this and then install this. You could curl the shell script and then run the shell script. It's going to install this for you. Basically, that's really the point. The main thing, of course, would be to have this in your path. So if I just run this command, Golang C, and I think it's called Golang C lint like this. Yep. So this is already, I have this in path. So the main point, of course, is after you download this, you need to have this added to your path so that you're able to use the command. And of course, this doesn't work alone, or mostly doesn't work alone. It will require a YAML file where you specify the linters, because of course there are lots of linters out there, and Golang CLint is more or less like a linting engine. You could think of it in that regard. So and what happens is that if you have the option of specifying the linters you require, and you also have the option of telling it to use every possible linter out there. But this is of course not recommended, because you could have your code, everything working quite well, and it happens that somebody somewhere publishes a new linter, is going to pull that new linter in, and if this in any way doesn't conform with the what you have already set up in your um, in your project, of course your build is going to fail. So I'm quickly going to provide is a Golang YAML file. We'll go through it a little bit and then we'll see what we have. Okay, so I've gone ahead to provide a Golang YAML file, and if you look in here, you can actually see that there are lots of things here, but you don't need to um, know what everything means for now. Again, like I said, I'm going to provide a link to the page, the home page more or less of Golang C. I think this should be at golangc.run. And then they also have a lot of starter templates that you can more or less pick up and put in your project with the barest, at least barest minimum requirements that your coding would need to satisfy or more or less comply with. So, but the important things I would like you to see, for example, would be this linters section. The first thing I have here is disable or true. So, like I told you initially, the standard thing more or less to do would be to basically disable all linters. And after that, under the enable block, you can now provide all the linters you need, and they do different things. So um, I also don't even know all of them more or less of heart, but of course you have the option of looking into each of these individual linters to see basically what they are doing. So this duple more or less makes sure that you don't have duplicate blocks of code in your project. And then I think GoConst makes sure that if you have, let's say we have somewhere in our code here that we used, I don't know, some string that we defined, the same string we use it at maybe 510 places. So this is going to force us to define a constant with that string and then use the variable that we've defined. So I think Go Critic more or less looks into like Go best practices, things like let's say if you do like a heavy just imagine, for example, if we had, I'm just going to show you an example. So imagine we have let's say I'm going to call this say users, something like this, and this is of, let's say this would be of type, I don't know, maybe I define a user here, user for example, and then I give it a name which would be a string. and an email, which of course be a string. And here, let's say users are of type email, sorry, user, and then I can maybe provide some users, for example. So if we loop through our users more or less, so let's say we have over here user, for example, and we are looping through users and maybe fmt.println, and then we are printing our user, for example. If we have something like this, oh, sorry, I need to get rid of this. So if we had something like this, if you do a for loop this way with a range over, let's say, an array of structs, in this case, user, and what is going to happen is, of course, this is going to get copied more or less for the number of times we have. Um, let's say if this array of users let's say 10 in length, so this is going to actually get copied 10 times um, when we loop over our variable this way. And so if you use this linter, for example, it's going to critique this method of looping through your variables, because again, it's going to point it out to you, okay, this is the problem, and it will advise you to more or less use either a reference to this variable or use indexing. So this is more or less what this does. I'm going to get rid of this. I need this anyways. So coming back here, of course, you already know gofmt. So this is going to, of course, take care of the formatting of your code and a lot of others. So this misspell, if, for example, over here, we did something like, instead of was, we'd have something like this. This linter here is going to say, hey, you made a mistake here. That's actually wrong. Might be a little bit annoying, but that's what it does. Again, like I said, in the end, you decide which linters you would want to use and the ones you want to get rid of. And the list is actually way longer than what I have here. I just have a much shorter list because I feel for me this is sufficient. And of course under the run section we have so normally I think the default exit code is always 1, so this more or less is not required. And of course concurrency is concurrency, so the timeout would be the timeout of running the linting, like you have over here. Default is 1 minute, and other of these other attributes we can set in here. So here I'm also specifying the Go version, and then for outputs I get to specify formats. And so there are lots we can do here, and to be honest with you, without even running the linter, I can already imagine there are probably lots and lots of ways that we are already violating, like the way we should have written our Go code. Because if we did something like, let's just go ahead and run the linter. So go what did we call it again? Golang c lint. I'll simply use the run command, Golang c run, and then I'm going to expand this a little bit and give it a couple of seconds or probably minutes, I don't know, for it to complete rather, and then we take a look. So the linting is done. As you can look over here, we have tons and tons. Maybe not so much for now, but some problems that we actually need to fix. And you also get the name of the linter that actually pointed out the error. So if you look here, for example, we have a string defined in this file. We can also go to the file. We have a string here defined, and it's telling us that we've defined the string 4 times. There are 4 occurrences of this string, so it's advising us to make it a constant so we can use it other places without copying the string all over the place, like I told you initially. And now you have over here, for example, it says user is heavy. It tells us the size of a user struct, and it asks us here to consider passing it by pointer. So if you look at the function, let's go there. So here is telling us, of course, that the size of this user struct we have here is 852 bytes, and it's advising us to pass this as a pointer, more or less like this. And what is, oh, sorry, crazy me. Of course, this should be this way. And then we have to find where this is used to fix the error. So here I can maybe remove this like this. And we fix this. So this is also something similar. Is asking us here to consider passing this by. It's also something similar. And then if you look over here again, we have some lot more recommendations. We also have the same user stuff here. We actually have somewhere shadowing, where an import is shadowing a variable that we have locally. So if you look here, we have a variable defined as db, but I think if you go up, we'll also have an import called db. So this is of course really wrong. It shouldn't be at all. And we actually have it in like 3 places. And yeah, we have a lot more things we have to look at. So I think here we are using a weak random generator, as we can see over here, and it's making a recommendation of what we could use instead. And other stuff like that we can use that. So we also have things like naming conventions. We having underscores in names, which shouldn't be, because in Go we are more or less advised to use camel case for variable names and stuff like that. And to also show you, if we come here and say the user, for example, and we put something like this and we spell this wrongly, if we run our linter again, the spell check linter will catch this and tell us, oh, we made a spelling mistake somewhere. Let's quickly look to see if we can find it. Hopefully we can find it. I don't think we can. So with the USRE, so we don't have. Do we even have the linter in the first place? So let me take a look again. Let's look at our linters. Go misspell. So I think, of course, we have a list here, but once we fix, because in the end these are actually not all the only problems we have. That's also what I can tell you from my experience. So if you look at this list, you might think it's actually a small list, but the point is you don't get all the outputs. I think there should be some form of settings you can put here in this file to dump everything on the console. But other than that, by default, you don't get the output of all the possible errors. So what happens is, when if you fix the problems and run the linter again, it will show you, it will throw out more errors basically. So, but the point, of course, is to make sure that you follow the defined and agreed upon Go style guide, more or less. And that's really the point of using the linters. And anyways, that would be all. Actually, that would be all I wanted to show you in this video. I'm really hoping this proves helpful for you. Again, remember what we tried to cover in this tutorial. So we looked a little bit at dependency management in Go. We looked a little bit at different ways of adding packages in your application and managing them. So we had Go get, Go install, Go mod tidy, Go mod download, and we again talked again about linting. Anyways, that will be all for now. I hope you've learned something in this tutorial. We are going to again continue like we agreed upon, and we are moving actually at a really nice fast pace, and I'm okay with that. If you look over here, we actually have more or less 4 more chapters, and then we'll be done with our tutorial. Of course, that would not be the end of our Golang journey, but of course, just like we agreed upon in the beginning, the goal of this tutorial will be to give you like a reference. If you are starting out, let's say, as a backend developer working with Go, or if you already are working with Go and you would want to check out and see how Tony does these things, this is of course should I would assume it would prove useful to you anyways. And that will be all for all now, guys. And yeah, please go ahead and subscribe, and of course hit the notification bell, because I try to provide or more or less upload videos as frequent as possible to always keep you learning more or less. So go ahead and subscribe, and we'll see each other next time, guys. Have a lovely evening, and bye bye.